Assalamu alaikum everyone. Let's start with part 2 of differentiation, where I'm going to discuss gradient of tangents and normals. The condition for gradient of tangent and normal is the same as the one that we studied in coordinate geometry. For example, if a line is tangent to the curve, then the gradient of the curve will be equal to gradient of the tangent. But if a line is normal to the curve, the gradient of the normal and the curve will be reciprocal and negative, right? So this is the same condition as we have studied in coordinate geometry. Now let's keep it aside a little bit and let's start with our question. Let's have a look at the question. Find the equation of the tangent and the normal to the curve this at the point where x is equals to 2. So let's first bring this denominator in the numerator before we find out the gradient through differentiation. So y is equals to 2x square plus 8x to the power minus 2 minus 9. Now we find out dy by dx of the curve, which is 4x plus 8 into minus 2 x to the power minus 3. dy by dx of 9 is equals to 0. So dy by dx becomes 4x minus 16x cube, or as we are going to use it as 4x minus 16 upon x to the power 3, because this is x to the power minus 3, goes back into the denominator. Now let's plug in x is equals to 2 in this gradient. So dy by dx is equals to 4 into 2 minus 16 upon 2 cube is equals to 8 minus 16 upon 8 is 2. Gradient is equals to 6 at the point where x is equals to 2. As we have to find out equation of the tangent and the normal, we need a complete point with y coordinate. So first let's find out y by plugging in 2 in the original equation. Y is equals to 2 into 2 square plus 8 upon 2 square minus 9 is equals to 8 plus 8 upon 4 is 2 minus 9, y is equals to 1. So we have a complete point, x coordinate 2, y coordinate 1. For tangent, we use the same gradient. Gradient is equals to 6. So y minus y1 equals m x minus x1. Y minus 1 equals 6 x minus x1. Y minus 1 equals 6x minus 12. Y minus 6x equals minus 11. This is the equation of the tangent. For normal, gradient will be negative and reciprocal. So I'm going to use gradient is equals to minus 1 upon 6. Equation y minus y1 equals m x minus x1. Y minus 1 equals minus 1 upon 6 x minus 2. 6y minus 6 equals minus x plus 2. 6y plus x is equals to 8. This is the equation of the normal. Let's move ahead. A curve has equation this, and the normal at point P and the normal at point Q intersect at point R. We have to find coordinates of point R. It means that coordinates of point R means it will have x and y both. So we will need two equations to find out the coordinates of point R, as the number of variables is equals to number of equations required. So let's first differentiate the curve. Dy by dx is equals to 3 bracket 4 minus under root x power 2, 3 minus 1 is 2, and differential of the expression inside is minus half into x to the power minus half, because half minus 1 is minus half. I can write it like minus 3 bracket 4 minus under root x power 2 upon 2 root x. At point P, which is a normal, let's plug in 4 first. So this becomes minus 3 bracket 4 minus under root 4 square upon 2 under root 4 is equals to minus 3 into 4 minus 2 is 2, 2 square is 4 upon 2 multiplied by 2 is 4. This 4 cancels, this is minus 3. But for normal, we are going to use the gradient which is reciprocal and negative. So gradient of the normal that we are going to use is 1 upon 3. Let's find out equation of the normal. We already have the point 4, 8. So y minus y1 equals m x minus x1. Y minus 8 equals m x minus 4. 3y minus 24 equals x minus 4. 3y minus x equals 20. This is equation 1. For tangent, for another normal at the point Q91, let's find out the gradient first. Minus 3 bracket 4 minus under root, the x coordinate we are going to put 9 upon 2 root 9 is equals to minus 3 into 4 minus 3 is 1, 1 square is 1 upon 2 into 3. This becomes minus 1 upon 2, but for normal we are going to use the gradient which is negative and reciprocal. So this was the gradient for point P, and now we are going to write gradient for point Q, which will be equal to 2. Now let's find out the equation. The equation is y minus y1 equals m x minus x1. Y minus 1 equals m x minus 9. Y minus 1 equals 2x minus 18. Y minus 2x equals minus 17. This is equation 2. Now I have to solve the equation simultaneously. What I am going to do is I am going to multiply this equation by 2. So this becomes 6y minus 2x equals 40. Y minus 2x equals minus 17. I am going to subtract both the equations. This becomes 5y, this and this cancels, equals 57. So y is equals to 11.4. Y is equals to 11.4. Now I put it back in equation 1, right? 11.4, or we can say 57 upon 5, whatever we want to keep it as. We can keep it as fraction, we can keep it as decimals. And 3y minus x equals 20. 3 into 11.4 minus 20 is equals to x. So this will be this is going to be 14.2. So the coordinates of point R are 14.2 and 11.4. These are the coordinates of point R. This is what we are looking for in part A. Now let's have a look at what part B is saying. Find the area of triangle PQR. So first we have to draw this triangle, and I'm going to draw this on a grid, right? I've already drawn this for you people. So this is the triangle, and you can see that this is point R, right? 4, 8 is point P, and this is point Q, 9, 1. Now I have joined all the corners to form a triangle, and finding area of this triangle is not easy because we don't have the angles. Also, this is not an isosceles triangle, this is not an equilateral triangle. So what we are going to do is, I have made a box around it. As it's on the grid, making a box is easy, and finding the coordinates, the missing coordinates of the box, is also easy. For example, which coordinates have I written on my own? Coordinate number 1 is this one that I'm highlighting in red because this is side of the box. How did I figure out the y coordinate? Because it's lying on the same height, so y coordinate of this one and R is going to be the same. Second one, I'm going to highlight in blue. 14.2 and 1. How did I find out x and y coordinate of it? As it's lying on the same line as this one, so x coordinate has to be the same. As it's on the same height as this one, so y coordinate has to be the same. I extend this line, and I'm going to highlight this in pink. So this is 4 because it's in the same line as this one and same height as this one. So finding the coordinates was easy, and this one 4 is in the same line as this one. So finding that coordinate was also easy. Now what are we going to do? We are going to find out, as we can see now it has become easy. Why it has become easy? Because now we have right angled triangles, right? We can find out the area of rectangle. Area of rectangle, let's name it, this is R. Let's name this R, PQR. This is S, this is T, and this is U. So rectangle R, S, T, U minus which triangle? I'm going to highlight the triangle in blue. Minus this triangle, which is QSR, minus another triangle which I am going to highlight in green, minus triangle QTP, minus another triangle which I am going to highlight in yellow. Triangle RUP, right? How are we going to find out dimensions of this triangle? It has traveled from 4 to 14.2, which is 10.2. This is one dimension for triangle. Triangle we only need half into base into height, right? So here we have 10.2. From 8 it has traveled 11.4, so this is 3.2. From 1 it has traveled 8, so this is 7. From 4 it has traveled 9, so this is 5. From 9 it has traveled 14.2, so this is 5.2. And from 1 it has traveled 11.4, so this is 10.4. Finding the area would be easy in this case. Okay, I'm not going to find out the area completely. I leave this here for you so that you can find out area yourself, and you can comment the area in the comment section. This is 3.4, not 3.2. Moving ahead, we have another question. Curve has an equation this, passes through points this. Find the equation of the tangent to the curve at point P at this point, and find the angle that this tangent makes with the axis. This is a different kind of a question. So first let's transform this equation into the one that we can easily differentiate. So we have y is equals to 5 bracket 2 minus 3x to the power minus 1. Now dy by dx is equals to 5 bracket minus 1, 2 minus 3x to the power minus 2, differential minus 3. So this becomes dy by dx is equals to 15 into 2 minus 3x to the power minus 2. At P, x is equals to minus 1. Put it in dy by dx. 15 into 2 minus 3 into minus 1 is plus 3 to the power minus 2. This is equals to 15 upon 5 square is 25. dy by dx is equals to 3 upon 5, and this is the same gradient that we are going to use for the tangent. Okay, let's find out find the equation of the tangent. Y minus y1 equals m x minus x1. Y minus 1 equals 3 upon 5 x plus 1. 5y minus 5 equals 3x plus 3. 5y minus 3x equals 8. This is the equation. Now it says find the angle that this line makes with the tangent. We can see that this line is a positive gradient. This line has a positive gradient because we can write it like this. 5y is equals to 3x plus 8. Y is equals to 3x upon 5 plus 8 upon 5. Now how do we find out the angle that it's making with the x-axis? Let's draw this. Now we find out the y-intercept. Intercept is the place at which, the point at which any line cuts the y-axis or any line cuts the axis. So y-intercept here is 8 upon 5. Let's mark it somewhere over here. 8 upon 5, and this is the x-axis, right? So let's mark it 0 over here, the origin. Now to find out the x-intercept, what do? We put y is equals to 0, right? We put y is equals to 0. So it becomes minus 8 upon 5 equals 3x upon 5. 5 cancels and x-intercept becomes minus 8 upon 3. Minus 8 upon 3 will be somewhere over here, suppose. Okay, now we draw a line. This is the line. This line will look something like this, passing through both these points. Now we can see that this is a right angled triangle. This length here is 8 upon 5. we want the angle with the x-axis, so this becomes the perpendicular. This length here is 8 upon 3. We can apply tan theta is equals to 8 upon 5 divided by 8 upon 3. So we multiply it by 3 upon 8, and one of them is negative. This length is negative. So what are we going to write? If we have a negative with this one attached, that basically we don't have to do that, but the value of tan that you will get will be negative. Why? Because in this quadrant tan is negative, right? Tan is negative. So what happens here is we have theta is equals to minus tan inverse 3 upon 5. When you find out the angle turns out to be 30.96. Theta is equals to 30.96. This is the angle that it's making with the x-axis, and this is going to be the theta that you will get here is negative if you place this negative sign over here. Let's move ahead. The curve y is equals to this crosses the x-axis at point this and this. We know that whenever any line or any curve crosses the x-axis, the y coordinate is 0. So we can see it very clearly in all 3 points. Y coordinates are 0. Now let's move ahead with this question. Let's first make this equation usable for gradient. So this is y is equals to x into x square plus 2x minus x is plus x minus 2. Bring this x inside, x cube plus x square minus 2x. Now we find out dy by dx of this curve. 3x square plus 2x minus 2. Now at a, x is equals to 1. We put this x is equals to 1 in dy by dx. dy by dx is equals to 3 into 1 square plus 2 into 1 minus 2. 3 plus 2 minus 2 dy by dx is 3. Now as this is the normal, the gradient that we are going to use is minus 1 upon 3. Let's find out the equation. Y minus y1 equals m x minus x1. Y minus 0, so I am going to let it be like this. Minus 1 upon 3 x minus 1. 3y equals minus x plus 1. 3y plus x equals 1. This is equation 1. For b, x equals minus 2. dy by dx equals 3 into minus 2 square plus 2 into minus 2 equals 12 minus 4 minus 2. dy by dx is 6. But as this is the normal, we are going to use m is equals to minus 1 upon 6. Let's find out the equation. Y minus y1 equals m x minus x1. Y minus 0, so I am not going to write it, minus 1 upon 6 x plus 2. 6y equals minus x minus 2. 6y plus x equals minus 2. I am going to add both the equations because I am going to eliminate x. Minus 2. 3y plus x equals 1. Minus minus minus. This becomes 3y. X and x cancels. Minus 3. Y equals minus 1. I am going to put y equals minus 1 in this equation. 3 into minus 1 plus x equals 1. X equals 1 plus 3 is 4. These are the coordinates of point C. Let's do another question. The normal to the curve y is equals to this at point this is parallel to the line this. So what have we studied? That the gradients of parallel lines are same. So let's first find out dy by dx from here. Dy by dx is equals to 4x plus k, because k is a constant, so differential of kx is equals to k. Here we can only put in x, but we will still have k in the gradient. So let's see, m is equals to 4 multiplied by 3, because at point this, plus k. So gradient is equals to 12 plus k. Another condition is that gradient at point, the gradient of the normal to the curve at this point is equal to this. So the gradient that we are going to use is m is equals to minus 1 upon 12 plus k. But this has to be equal to here. So the gradient here is minus 1 upon 5. So minus 1 upon 5 is equals to minus 1 upon 12 plus k. This minus cancels, both of them cross multiply. 12 plus k is equals to 5, k is equals to minus 7. This is the answer. Part B says, find the coordinates of the point where normal meets the curve again. So we have to find equation of the curve first. Equation is y minus y1 equals m x minus x1. This is the gradient of the curve. So a gradient of the normal, y plus 6 equals minus 1 upon 5 x minus 3. 5y plus 30 equals minus x plus 3. 5y plus x equals minus 27, right? So we make y the subject. Y equals minus 27 minus x upon 5. We put y here so that we can solve simultaneously. So this becomes minus 27 minus x upon 5 is equals to 5 comes here. This is 2x square minus 7x minus 3. Minus 27 minus x equals 10x square minus 35x minus 15. Bring everything on one side. 27x square minus 34x minus 15 plus 27 is 12. Plus 12 equals to 0. Divide the entire equation by 2, becomes 5x square minus 17x plus 6 equals to 0. Multiply these two, factorize. 5x square minus 15x minus 2x plus 6 equals 0. Make factors, 5x common. What's left inside is x minus 3 and minus 2 common equals to 0. X is equals to 3 and x is equals to 2 upon 5. X is equals to 3 is one point where we know that this normal to the curve meets the curve at this point, and we are going to put 2 upon 5 into the original equation to find out the other point where this normal meets the curve again. We plug 2.5 in the original equation and we get the value minus 137 upon 25. That is it for today. We are going to move ahead with second differentials in the next lecture. Till then, you take care. Allah Hafiz.